ununiformed search algorithm, or you can say that as a blind search algorithm. Okay. So first we'll see, as I said in the previous class, the first one is the first one which we can see is breadth first search. This can be called as BFS algorithm. Okay, a breadth first search algorithm. So this breadth first search algorithm, this commonly have a search a strategy for traversing the tree or graph. So traverse strategy, traversing a tree or in the form of graph you can represent. Okay. The next one is the algorithm searches breadthwise. So here, why it is called as breadthwise? It's search breadthwise. That is left to right, left to right. In a, it may be tree or graph. So you are going to represent in the form of tree or graph. Whatever it may be, tree or graph, it will search breadthwise. That is from left to right. Then this search starts searching from a starting node of a tree or a graph and expand to the successive nodes and the current level before moving to the node at the next level. So what it will do, it will start from the start node, then it will go to all the successive success nodes at the current state, at the current state. Then it will move to the next successive, like keep on, it will go until it reaches the goal node. So the BFS algorithm is an example for general graph search algorithm. Okay, it can be implemented using this will be implemented using FIFO. Okay, so FIFO data structure. So this is how they will do. So this is a breadth first search algorithm. Then we will go for the advantages of it. So it will provide solution. If in a given problem, if there is a solution, it will definitely provide a solution. So will provide solution if it does exist. Okay, and if more than one solution for a given problem, then it will provide a minimal solution which requires the at least minimum number of steps. Like that it will give a minimal solution. Okay, more than, if there is available of more than one solution for a given problem, it will provide a minimum solution. So minimum solution will be provided. So this is the advantage of this DFS. And coming to the disadvantage, it requires a lot of memory because it is sensing all the nodes in the transverse wave, all the successive nodes, and it will expand to the next level until it reaches the goal node. So it requires lot of memory, and then BFS needs lot of time to solve the solution. So both memory and time is required for this BFS, breadth first such algorithm. So I will explain this with an example. Okay, so you'll have a better understanding. So assume that this is tree. So these are the nodes. So assume that this is the goal node. So here it has to reach to the K node. And this is the initial node, level 1, so initial state, initial node or state, and it has to reach to goal. So assume this to be level 1, and these two will come under L2, level 2, and this is level 3, and this is level 4, and this K node is level 5. So what is the procedure here? This will start with this particular node. It will go like this. It will come here, and then it will search here. Then again it will come here, and it will search all these nodes. Then again it will come here. It will search all these nodes, and finally it will reach the destination node. So this is the procedure. So, for any search algorithm, what are the three types? One is completeness. Yes, it is complete. Completeness. Yes, it is complete because it is giving a solution. So, is it optimal? Yes, it is optimal because it is giving the best solution. Optimal. According to their law, it is giving. And time complexity. So time complexity, if suppose to determine time complexity, it will be, you assume D is equal to depth of solution. Here shallow solution, okay, shallow solution, and B, assume B to be a node at every state. Every state you have to check the node. So to find out the third one, complexity is represented by T of B, which will be equal to B power 0, B power 1, like that, B power 2, it will be going on, B power D. So B power 0 is 1 plus B square, it will be going on at B power D. So what is the remaining one? So the formula is 0 B power D. This is complexity representation. Similarly, space complexity will be represented by, fourth one is space complexity. Space. Okay, time, this is time complexity. This is space complexity. Space complexity is represented by S of B. So that is complexity will be B into D. So this is the formula. So it requires a lot of memory, lot of space, but it is having the best solution. This is the procedure for finding out. Next, now I'll give a problem to find it. So find the root from S to G. Problem is S, A, B, C all are connected to S. Then here D and here G. These two are connected. This one is connected, this is connected, this is connected, this is connected. Assume like this. So here I will give some weights. These are all weights. 5, 3, 1, 4 random weights I am assuming, or it has been given here in the problem. So this is the example. For this, we have to find out the root from S to G. So that is the thing. So first step, what is the first step? Step 1, level 1. So we know what are the levels available. Level 0, this is level 1 and level 2. So to level 1, level 2, level thing is there. So first step 1. Step 1 is, what is that? S is step 1. And step 2. Step 2. So now S is connected to what are the things? A, B, C. If the what is the weight? 2, 1, 5. This is step 1. What is step 2? So step 3. How this next step is connected. So yes, A is connected to B. Similarly, B is connected to D and G. Similarly, here C is connected to G. Okay. So now this is step 3. So now we have to see what is step 4. Step 4. What is step 4? Yes. S is connected to A, B, C, and A is in turn connected to D, and D is in turn connected to G. So that is one completeness. And here what is B? B is connected to D, and D is connected to G. That is next completeness. And here B is connected to C. C is connected to G, and then B is connected to G. So all the connection is over. So now if you are marking level 0, level 1, level 2, and this is level 3. So now if you see, all are connected, all have connected to the goals. So now which are the 2 goals which is important? So here if you see the goals which is attained here, this is the minimum goal, minimum thing. So for answer for this is, it can be either S, D, G or S, C, G, because this is the 2 things which is giving the goal earlier compared, that is in the level 2 itself we are achieving. So even if it is the more number of solution, it will give the good solution. That is the characteristics. So this is the method of finding out. See, it is traveling to all and it is finding out the goal. So everything is finding more number of goals are reached, but which is a quickly minimum number of steps. So how we are getting, that is what important. Hope you understand, student. Thank you. The rest we'll see in the next class. Okay.